Good morning. We will start session 3 on chapter circles. So we started with an exercise. We had done up till 8 sums. From 9th one we will start now. The figure is already given. So the 9th sum is in figure xy and x dash y dash are the two parallel tangents to a circle with center O. So this is the given figure. This is the circle and this is the center O. Point of contact P and point of contact Q. With respect to that, I have two tangents, which is x dash, y dash, and this is xy. Right? Then there is another tangent AB. So with respect to this point, okay, this is some point y I consider here. Wait a minute. So this is y. There is another tangent at a point of contact C, which is AB. Intersecting xy at A and x dash y dash at B. Prove that AOB is 90 degree. So given tangents xy is parallel to x dash y dash and tangent AB is at a point of contact C. Tangent AB at point of contact C. Now what I have given, prove that angle AOB is equal to 90 degree. So we have to say in the given, join OA and OB. That's all. To prove angle AOB is equal to 90. Construction, join OC. Right? So what we will do now here is, we will take these two triangles and prove them they are congruent. Choose these two triangles and prove them they are congruent. First we will do that much, because we need to prove that this angle is 90. For that these things are required. We anyhow know that this is 90 degree, this is 90 degree, this is 90 degree, and this is 90 degree. Why? Because tangent radius theorem that we can write whenever we are writing this part here. So I'll choose these two triangles first. Or I hope if this part is clear, what I will do is I'll erase this much of part where I have written given, to prove, and construction. I'll freshly start this from proof now, because I'll get that much of space to prove it. So proof. First, as I have told, these two triangles I consider. In triangle OPA and triangle OCA. First of all, I will write angle OPA is equal to angle OCA is equal to 90. Together you can write the reason as tangent radius theorem. If not this, you know what to write. Tangent at the point of contact of radius is perpendicular or 90 degree. These two angles are 90. Can I tell OP is equal to OC? Why? OP is equal to OC. Radii of same circle. Then the next part here, OA is equal to, no, not that. The next one I can tell here is AP is equal to AC. See here. First of all, 90 degree, 90 degree, that was clear in these two triangles. This side is equal to this side, that's because radii of the same circle. AP is equal to AC. Why? How is AP is equal to is AC? That's only because they are tangent from the external point. Length of the tangent drawn to a circle. So this is an external point A. This is the tangent. This is the tangent. That means they have to be equal. So tangents drawn from external point are equal. Okay, 90 degree, then we have a 90 degree, but we have other two sides, but we do not have a hypotenuse here. Do we have a hypotenuse? Now this was the hypotenuse, or else what we can say is here, this is one common side. Now see here children, I have used down these three things. That means I can prove this by SAS. Okay, keep this aside. I have chosen these two triangles. I will not choose the common radii. I will choose that this is 90, this is 90. Tangents drawn from external point are equal. I will say that OA is the common side. That is nothing but the hypotenuse. I can also prove that by RHS. Both are equally correct. Depends upon what parameters you have chosen. It's a common hypotenuse for both. So what we will do here now? Triangle OPA is equal and congruent to triangle OCA by SAS. SAS congruence rule. From this I will tell now these two angles are equal. CBCT. Angle OAP is equal to angle OAC. Reason CPCT. Now these two angles are equal, right? Which is nothing but half of this I can tell, half of the whole angle, half of nothing but P. See here, PAB is nothing but PAC. Both are equal, right? So I will consider this part of the angle as OAP is equal to OAC. I will rewrite this as OAP as this is equal to OAC. I will extend it till B. This angle OAB. Both are same. Okay, just have extended. Further, from this I can assume that therefore angle OAB is equal to half angle PAB. Equation 1. Very clear? These two are bisectors. They are equal now. The whole angle is nothing but half of this angle. I can also write it in that manner. I have written it equation 1. Similarly, if I choose these two triangles and prove them congruency, I will get that this angle is equal to this angle. Therefore, this angle is half of QBA. Can I write? Now, similarly, I will write here. I will again, if I choose, I have to prove congruency. I will get CBCT and I will get that. So simply, I will write similarly angle OBA is equal to half angle QBA. Angle OBA, this angle I am talking about now, is equal to QBA. Half angle QBA. Equation 2. It's very clear till here. Okay, the sum further still continues children. Now, we are talking about this angle here and we are talking about this angle here in terms of half. Do we know that XY is parallel to XYY dash? Yes. Now I will write here XY parallel to X dash Y dash. Therefore, angle PAB plus angle QBA is equal to 180. Equation 3. Angle PAB and angle QBA is equal to 180 I have written. Why? Because interior angles on same side of transversal is supplementary. We know this. Is it very clear over there? But here, see children, what is PAB? OAB is equal to half of this we have written, right? So can I take this 2 here and I can say PAB is nothing but 2 times of angle OAB. Can I write? Plus, if I shift this 2 here, QBA is nothing but 2 times of OBA is equal to 180 from 1 and 2. Okay, I will take 2 common. Angle OAB plus angle OBA is equal to 180. Send this to this side. Angle OAB plus angle OBA is equal to 90. Equation 4. Right? We proved that angle OAB and angle OBA is equal to 90. Keep it as it is. Last part now. In triangle AOB, angle OAB plus angle OBA plus angle AOB is equal to 180. Reason? Angles of property. These two angles together is 90. Here it is. Plus angle AOB is equal to 180. Reason I will write from 4. 180 minus 90 is 90. Therefore, angle AOB is equal to 90 degree. Okay, remember this. Sometimes directly this question is asked in MCQ. If this is the given figure, what is the measure of AOB? You have to remember that measure of AOB is 90 degree. Direct question for MCQ it is asked sometimes. So it is 90. We can also prove that if it is asked for 3 or 4 marks. Now here I have written this similarly. Directly I have taken this angle. In your school, if they tell that no, you have to show congruency for both the triangles and this relation should be obtained after proving congruency only, you have to go ahead. You usually get marks for such sums when you write similarly and you have to go ahead with this. Right? So this is how we do that. Next one. Prove that the angle between two tangents drawn from external point to a circle is supplementary to the angle subtended by the line segment joining the points of contact at the center. In simple terms, if I have to tell, whenever we draw a tangent to a circle from an external point, those tangents are equal, right? Then the quadrilateral so formed is nothing but a cyclic quadrilateral. In a cyclic quadrilateral, what is the property? Opposite. Some of the opposite angles are supplementary. That is what we have to prove it here. They have given inclined angle and the subtended angle here, both. Inclined angle, yeah, and angle subtended by joining the line segment. That is what the meaning of the given question. Tenth one. So first of all, we'll draw. This is external point P, this is A, this is B, O is the center of circle. Okay. Now we need to prove that this angle plus this angle is 180 degree. This is 90. Given O is the center of circle. PA and PB, PA and PB are the two equal tangents from external point P. Okay, to prove angle AOB plus angle BPA is equal to 180. That is what they have asked us to prove here. Proof AOBP is a cyclic quadrilateral. If you write it, we have to do that. We'll just mention that it is a quadrilateral here. Because in cyclic quadrilateral directly we can arrive at the answer. Is a quadrilateral. So angle AOB plus angle BPA plus angle PAO plus angle, which angle? OBP is equal to 360. And it's a property of a quadrilateral. Now AOB as it is plus BPA also as it is plus PAO is 90, OBP is also 90 is equal to 360. Reason I will write OA perpendicular to PA and OB perpendicular to PB. Reason tangent radius. Reason always you have to mention tangent radius theorem. Over. So angle AOB plus angle BPA. What is 360 minus 180? 180. 90 plus 90 is 180. Hence proved. Right? Very simple one. 11th one. Prove that the parallelogram circumscribing a circle is a rhombus. Remember yesterday we had done a quadrilateral ABCD is drawn to circumscribe a circle. Prove that we had written. It's the same thing. Till there we have to prove it similarly. Later it is a rhombus we have to prove. What is the property of a rhombus? Side property. All the sides are equal. Yesterday it was a type of a quadrilateral here. Now here the circumscribing is not a quadrilateral, it's a parallelogram. Already in a parallelogram, opposite sides are equal. Now we have to prove that adjacent sides are equal. So as it is, first we'll draw a circle. To that we will adjust a parallelogram, whatever it is. Okay. A, B, C, D is a parallelogram and the points P, Q, R, S. Okay. Given 11th one. O is the center of circle, right? Then ABCD is a parallelogram circumscribing the circle. Now what we have to prove? We have to prove that ABCD is a rhombus. ABCD is a rhombus. Okay. Same like yesterday's, we will start with now. Proof AP is equal to AS. Now I have told you how to choose. Since I have chosen AP, I will choose BP only. BP is equal to BQ. Since AP is chosen, we will choose the next as CR is equal to CQ. Since CR is chosen, DR is equal to DS. Tangents drawn from external point are equal. Okay, add the above equation. So AB plus BP plus CR plus PR is equal to AS plus PQ plus CQ plus DS. AB plus BP I will get AB. CR plus DR I will get CD equal to AS plus DS. If these two if I add I will get AD. BQ plus CQ I will get BC. But I again got the same time here. It's a parallelogram, children. So shall I write this as AB plus AB is equal to, here I will write BC plus BC. Reason, AB is equal to CD and BC is equal to AD. It is a parallelogram. Opposite sides are equal. 2 times of AB is equal to 2 times of BC. AB is equal to BC. AB is equal to BC. Adjacent sides are equal. This implies AB is equal to BC is equal to CD is equal to AD. Therefore, ABCD is a rhombus where all the sides are equal. It's same till here, what we had done yesterday. We only wrote now, since it's a parallelogram, opposite sides are equal, we applied that and we proved that adjacent sides are equal and it is a rhombus. The next one, the last 2 sums of the exercise. Now the next sum is something related to, if you remember in standard 9 you had Heron's formula to find area of a triangle. Now we all know how to find area of a triangle. What do? Half base into height. If it is an equilateral triangle, the formula is root 3a square by 4. But if it is a what you can say an isosceles triangle or a scalene triangle, how can you find the area of triangle when height is not known? At that point of time, Heron's formula is used to find area of triangle. So that we had learned the chapter itself, it was a chapter name itself was Heron's formula, where we learned to find area of different types of triangles. The same rule is applied here also. Triangle ABC is drawn to circumscribe a circle of radius 4 cm. So we'll first draw a circle. I think I'll just go with a bit bigger circle. Okay. Now draw a triangle so that you can adjust it. Okay. So this is B, this is C and this is A. ABC is a circle drawn to circumscribe a triangle ABC is drawn to circumscribe a circle of radius 4 cm such that the segments BD and DC, into which the segments, this is D, the segments BD and DC, which is divided by the point of contact D, are of length 8 cm and 6 cm. So first is DC. So this is 8 cm and this is 6 cm respectively. That side comes first. Find the sides AB and AC. So only this much is given to us. So this is D. Point of contact is E. Point of contact is F. Let us consider. Now since this is 6 cm, can this also be 6 cm? Tangents drawn from external point are equal. Since this is 8 centimeter, this is also 8 centimeter. Tangents drawn from external point are equal. Now these again are the tangents drawn from external point. So if this is x, this is also x. Right? Now what we have to do here is, we have to join OC, join OB and join OB. Right. So find the sides what they have given us. We'll just mention 12th one. In triangle ABC, so BC is equal to 6 plus 8, that is equal to 14 centimeter. So we'll consider that as A part it is. A, B, C we have to consider. By Heron's formula we require ABC. Next I will take AB, that is equal to x plus 8 centimeter, that is equal to B I consider. Next is AC is equal to x plus 6 centimeter, that is equal to C. Okay. The join, if you want you can write here, join OC, OB and OA. Now we know semi-perimeter we find is equal to A plus B plus C divided by 2. That is why I named that as A, B and C there for our reference. S we require to find that is semi-perimeter of a given triangle. Now how the semi-perimeter by, you have studied Heron's formula, that is what I am applying. What is A? 14. What is B? X plus 8. What is C? X plus 6 divided by 2. What all we had taken the parameters there, the same thing we added. X and X, 2x. So 14 plus 6 plus 8 will give you 20 plus 8. 28 divided by 2. I think you can take 2 common. X plus 14 divided by 2. S is equal to 2 and 2 will get cancelled. X plus 14 centimeter. Okay. I require a lot of space, children, for this. So I will do one thing. I will do this half part of the sum here. Then later I think I have to erase this because I again require this part. Or this much you have understood. I will just write here so that I will make use of it. S is equal to x plus 14 centimeter. Okay. I'll only rub this much of part now. Let the upper part be. Right? I'll clear this. Okay. Since let us find area of triangle now. Area of triangle ABC. What's the formula? S of S minus A, S minus B, S minus C. Area of triangle using Heron's formula what we find. So equal to root of what is S? X plus 14. S minus A. What is S minus A? Again, I will write a bit from here because lots of space is required for that. Is equal to. So this is x plus 14. Okay. S minus A. S is x plus 14 minus what is A? 14. S minus B. X plus 14 minus what is B? X plus 8. X minus 8, because minus sign what I have to use here, I have just opened the bracket. And the last part. This root actually continues here, children. Usually we are not supposed to write it down. I don't have a space because I have drawn a triangle. You can plan and do it here where you have enough space for this. So this also comes under the root only. The next is x plus 14 minus x plus 6 minus x minus 6. Simplify the bracket. Plus 14 minus 14 plus x minus x plus x and minus x. So x plus 14. Here 14 minus 8 you will get it as 6, and 14 minus 6 you will get it as 8. One more x is remaining here. 1 second. This x will remain here. Then you have a 8. You have 6. 14 minus 8 is 6, and 14 minus 6 is 8. This much is remaining as a root. So that is nothing but area of triangle ABC. Okay, keep this as this. Don't do anything with this. Next, area of triangle. I know we can simplify. 6 8s are 48. We can take. As of now, we'll keep it as it is first. Area of triangle ABC is equal to. If I take this bigger triangle, the triangle is divided into 3 triangles again. This triangle, as well as this. Yes, children. One more thing what you have to do, I forgot to inform you all is, we have joined this. Along with that, we have to join OE, we have to join OF. If you read the question correctly, they have given that the circle has a radius 4 cm. This is radius. OE is radius, OF is radius. We haven't joined that. So please join that. When you have written join OA, join OD and join OB and OC you have written. Along with that you also write join OE and OF. Please mention that also. Is nothing but area of triangle BOC plus area of triangle AOB plus area of triangle AOC. What is area of triangle ABC? Substitute. X plus 14, x of 6 of 8 is equal to area of triangle BOC is half into base. Base is what? BC. First I will write that. What is height? OD. Height is always perpendicular. Radius, what we can say. Radius at the point of contact of tangent you can tell. So height is OD plus half into AOB. Base is AB. Height is OE plus area of triangle AOC. Base is AC. Half into AC. Height is OF. Substitute. X plus 14, x of 6 and 8 is equal to half into 8 plus BC is 8 plus 6, 14 into OD is 4 plus half into AB. AB is x plus 8 into OE is 4 plus half into AC. AC is x plus 6 into OF. OF is 4. Everywhere 2 ones are 2 twos are 2 ones are 2 twos are 2 ones are 2 twos are. So finally we get this as x plus 14 x of 6 of 8 is equal to 14 twos are 28 plus 2 of x plus 8 plus 2 of x plus 6, right? Now I'll keep this, children. I'll erase the whole part that's required because the sum still continues. I can't be doing this down. Okay, I'll keep this here. I'll erase this much of the part from the beginning of the sum. Simplify the bracket. So x plus 14 of x of 6 of 8 square root is equal to 28 plus 2x plus 16 plus 2x plus 12 is equal to again x plus 14 of x of 6 of 8 is equal to, so 28 plus 16 plus 12, you will get that as 56 plus 4x. Take 2 common. I am just doing everything stepwise without even missing any step. So take 2 common, or what we can do is here, yes, or we can take 4 common. 4 1s are 4, 4 4s are 16, 14 plus x. Finally, squaring on both sides. Squaring on both sides. The root and square will get cancelled here when we square it. So what we have here? We will have here as, I will keep this as it is because I can cancel few terms later. X plus 14 of x of 6 of 8 is equal to 4 square plus x plus 14 whole square. Okay. So x plus 14 of x, 6 4s are, okay, 48 you write if you want, is equal to 16 of x plus 14 whole square. I will not substitute that. I'll tell you why. Now 16 1s are, 16 3s are. 3x of x plus 14 is equal to x plus 14 whole square. 1x plus 14 and 1x plus 14 will get cancelled. That is why I did not simplify. 3x minus x is equal to 14. Simple. If this will come down, one term will get cancelled. So 2x is equal to 14, x is equal to 7. Finally, we got x value. Now what are we supposed to do? Now last step, since we got x value, we already know that BC is equal to 14 centimeter. It's already given. AB is equal to 8 plus x. 8 plus 7 is equal to, next, 15 centimeter. AC is equal to 6 plus x. 6 plus 7 is equal to 13 centimeter. So measurement is 14 centimeter, 15 centimeter and 13 centimeter. This is how we do the sum. Quite a lengthy sum, but it's actually very simple if you go to see. It is only the values where neatly you have to substitute. Do it very carefully. I have erased few parts as and when I proceeded with the sum, so you know which part to write and how to proceed and how to end the sum finally, right? Do it neatly. And the last one. So let me erase this. Prove that the opposite sides of quadrilateral circumscribing a circle subtend supplementary angles at the center of circle. So we have a circle to which O is the center of circle. So this is the quadrilateral. Let us consider ABCD as per their given. P, Q, R and S. Now what they have asked here is opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. So I have to first join OA and OB. Now, one more thing here, children. This O will not be actually the center, or you can say, because otherwise it will become a straight line sometimes. They have not given. Where we have to join, they have not given. Prove that the opposite sides of a quadrilateral circumscribing a circle subtend supplementary angles at the center of the circle. Okay, and the center of the circle is here, but make sure that none of the angles form are vertically opposite or something. Just join these angles here. So once you join this side also. Now they look actually the same, this angle and this angle, right? It is not that. We have to prove that the opposite angles are supplementary. This plus this, when you add, you have to get 180. That is what they are saying. Or this plus this, when you add, you get 180. Also join this part. O. So given, you can say a quadrilateral ABCD, a quadrilateral 13th sum. ABCD is drawn to circumscribe a circle. Okay. Then here only we will say join OA, OC, OP, OR, OB, OD, OS, OQ. See if any of the part if I have missed. Just say that join all these things. If I have missed anything, please write it off. To prove, what we have to prove here, angle AOB plus angle COD is equal to 180. First one. Second one, angle AOD plus angle BOC is equal to 180. We'll prove any one variant here and we'll say that similarly we can be doing the next one also. So we will number these angles actually. It will be very easy for us. I will start numbering anyhow you can number. I mean from whichever part you want you can number. 2, 3, 4, 5, 6, 7 and 8. It will be very easy for us to write and term it. Otherwise very difficult it will be, children. So we'll just number these angles. Start proving congruency by taking two triangles at a time. Any pair of triangle. Say I take 1 and 2. Then you can take 3 and 4. Then you can take 5 and 6. Then you can take 7 and 8. Okay. Let's only take 1 and 2 and show that it's going to be same for other set of triangles also. Prove. In triangle SAOS and triangle AOP. Okay, first of all here I can tell that this angle is equal to this angle. Reason 90 degree. Why? Because tangent radius theorem. Angle ASO is equal to angle APO is equal to 90. Tangent radius theorem over. 90 degree part is over. Then I can also use another saying that AS is equal to AB. Tangents from external point are equal. Shall we use RHS now? OA is equal to OA. Common side. It's actually hypotenuse OA. Common side. Therefore, triangle AOS is equal and congruent to triangle AOP, a 90 degree hypotenuse at any one side by RHS. See, I can also use this as OS is equal to OP, radii of the same circle. But here that time what will happen is, it will not be proved using SAS here. Why? Because angle is somewhere and the side is, okay, it can be done, I'm sorry, one side and this, it can be proved by SAS also. I can do, same as the one some children, 9th one which I started today, similarly it can be proved. Now I have taken RHS, congruence rule. So, since triangles are equal and congruent, can I tell angle 1 is equal to angle 2? CPCT. Similarly, okay, is this concept very much clear what we have done? Shall I erase this? A little bit more is there. We proved 1 is equal to 2. Similarly, I can prove 3 is equal to 4, 5 is equal to 6 and 7 is equal to 8. We need not show that, we can only write it. So, I will write here. So, we wrote angle 1 is equal to angle 2. It was by CPCT. Similarly, I will write angle 3 is equal to angle 4. Angle 5 is equal to angle 6 and angle 7 is equal to angle 8. Okay. Next, we know that angle 1 plus angle 2 plus angle 3 plus angle 4 plus 5 plus 6 plus 7 plus 8 is equal to 360. Complete angle at the center of the circle is 360. Reason? Complete angle. But angle 1 is equal to angle 2. Angle 3 is equal to 4, 5 is equal to 6 and 7 is equal to 8. Write in that terms. See and write. You want AOB triangle part, right? Angle 1 is equal to angle 2. 2 times of angle 2 I will write. Plus 3 is equal to 4. 2 times of angle 3. I can write 2 times of angle 4. It is of no use to me. I am looking for AOB angle for that. Because 2 plus 3 will give me AOB. Look for that and write. Plus, I want now this side. 5 plus 6. I will write this as 2 times of angle 6. 7 plus 8. Nothing but 2 times of angle 7 is equal to 360. 2 common if I take angle 2 plus angle 3, angle 6 plus angle 7 is equal to 360. What is angle 2 and 3? Angle 2 and 3 is nothing but angle AOB. Plus, what is angle 6 and 7? Is nothing but angle COD. Is equal to 360.2 is nothing but 180. Okay. Again, also this same part can be written as, I want in this form now, right? Angle 1 is equal to angle 2. I will write here the same thing. If I repeat it, instead of I will write 2 times of angle 1. This is equation 1 will take here. From equation 1. Instead of this, forget about this. Again, same thing we are pairing. I will write down 2 times of angle 1. This angle I have chosen. 3 and 4 is there. 2 times of angle 4 I will write. Plus 5 and 6 is there. 2 times of angle 5 I will write. Plus, next is what? 5 and 6 is over. 7 and 8. 2 times of angle 8 I will write. Is equal to 360. Right? Group these terms. These two 1 and these two in 1. So, 2 common if I take. Angle 1 plus angle 8 plus angle 4 plus angle 5 is equal to 360. What is angle 1 plus 8? 1 plus 8 is AOD. Angle AOD plus what is angle 4 plus 5? BOC. BOC is equal to 360 divided by 2 is 180. This is how we prove it. Clear? That's why I told you we'll use numbers. If I go on writing AOP, POB, whole thing will mess up and we'll forget what two times and what one time will not remember. This is the simple technique what we can do and use. And with that we complete the chapter circles. A very important chapter where we have few theorems and some right